Hello and good evening. Welcome here on Faculty of Mathematics and Physics of Charles University in Prague. And before we start with these interesting talks and before we introduce our welcome guests, I would like to thank Karel Zikmund, Software Engineering Manager of .NET team at Microsoft. And without his help, it wouldn't be possible to organize this event. And maybe I give a word to him and he will introduce you like the talks and the guests.
Right. Thank you, Pavel.
All right, so hello everyone. It's great to be here back at my alma mater. So let's get going. I would like to start with first introducing.
Hello and good evening.
So as you've noticed, we are live streaming. We have 39 people online, which is awesome. We have them almost here now with us. I don't know, I can't see. Can I see the slides actually over here? No, I cannot. Alrighty. So I would like to just thank Pavel. He's from the university over here, and Carolina. She's actually from the the career. I'm not gonna try to say but she's awesome. She helped to make this happen. This is actually not the first event I'm gonna mention, and this is about me, Karel Zikmund. So I'm from this university. I'm actually originally organizer of NMM. If you have heard about that, like we have FICOS, Prase, and other correspondential seminars for high schoolers. So this is my way how to kind of upgrade, and now I can hopefully help a little bit students. And I'm on .NET team for last 14 years, based in Seattle. I'm moving back next year, and that's why I'm ramping up slowly my events over here in Czech Republic, which I started 2 years ago, independently. Hopefully gonna have some fun. I'm community manager. I do meetups around the world. Well, first in Europe, and a couple of weeks ago I did actually Australia and New Zealand. It was pretty, lots of fun. I want to mention that if you see that over here on the organizers, there's no Microsoft, and there's a reason. This is kind of a privately organized event outside of Microsoft, so this is not a recruiting event. I'm gonna have a word over there, just a small sentence. But my key goal over here is actually to help students find out how to find interesting jobs in, outside of Czech Republic, outside of Prague, or inside Prague, like internships, full-time jobs. If it's something you're interested in, you're gonna see that we have something prepared for you. But on top of that, feel free to, reach out, tell me. I'm more than happy to always kind of give advice, not only for Microsoft. Don't worry about that. Alrighty, one more slide if it works out. And it does not right now. Right now. All right. Okay. Thank you. You helped me out. So this is the list of events that are gonna be happening. So the first one is actually Meet Microsoft event. That's next week, next Thursday. You're not gonna see the link over here, but if you take the QR code or the nice aka.ms/matfis, it's not only for Matfis. Do we have anyone from Chvut over here? Raise your hands. All right. Quite a few. I mean, 6. That's good. So it's not only for Matfis, but it was easy for me to kind of put it, and it's easy to remember. Anyway, so we're gonna have the Meet Microsoft event, so you can go to the office. Details are on the page at the bottom, by the way, and resources. We will have Scott Hanselman. Who knows Scott Hanselman? Okay, 7, 8. Well, Jared, come on. Oh my goodness. Anyway, Scott Hanselman will be here. We will have actually a few seats saved for students. So if I didn't put that information on there. Anyway, talk to me if you want to go there. I'm more than happy to kind of set it up for you. And we're gonna have actually in February, that's Tuesday, Tuesday the 4th, that's when I'm gonna be here. It's not April, this is the American way. Software developer way. We're gonna have actually discussion with university students. That's something we did in May, and because it was last minute, Carolina warned me, nobody's gonna show up. It's end of the exam time, and nobody showed up. I mean, it was like 5 of us and 5 of the students. It was awesome, bottom one. Hopefully we're gonna get a little bit more attendance. I actually brought a couple of my friends who are not in Microsoft. I was the only one from Microsoft, but who went through interesting careers in their lives, either in Czech Republic or outside. There was actually Hanka from Oracle. There was actually Martin Ducháček from RSA, and a couple of interesting people. So if you want to find out, what career advice or whatever, some Q&A, come to that event. That's gonna be cool. And by the way, Microsoft, that's the, this is now Microsoft, hiring event a little bit. We're hiring Microsoft Development Center. If you don't know, actually in Prague, we have 400 developers right now. And we have actually a .NET team over here. One of them is mine, roughly 30 developers. It's pretty cool. And if you don't know, you can actually get Azure subscription for students for, kind of free. You can do kind of lots of cool things in there. Spin up your VM, do whatever you want with that and that stuff. Anyway, take a picture, because otherwise it's gonna go, and I'm gonna introduce Miguel. I need to thank Miguel a lot for coming to this event, making time, and tell you something.
All right.
This is Miguel. Who knows Miguel? All right. So, yeah, half of them.
I might have said things that I regret.
And something tells me it's going to be worse suddenly.
On those devices, we like it, we love these mobile things, and we love .NET. But there was a time, many years ago, I'm just looking at you, and while I look at myself, I'm actually very old, and many years ago, Microsoft dominated the industry, the PC industry. There were no mobile phones. I'm talking that way because I see that some of you are quite young. And there were no mobile phones, and they dominated the PC industry. And they made all of their software proprietary, and they hated Microsoft for that. And there was this dude out of MIT called Richard Stallman, and he was pitching this idea of a completely free operating system. Not free in price, but also you could get the source code to the operating system, and you could modify the operating system. And that was incredibly inspirational to me. I wanted to be part of that effort. So around that time, I worked in the Vue project, and I worked in the Linux project, and I did a bunch of different things. And ever since I read the Vue manifesto, I've been trying to destroy Microsoft. Now I work for Microsoft now, and we'll get to that. But I've been trying to destroy Microsoft for as long as I can remember. Somebody was telling me in the train I wasn't born in 1992. Where are you? No, where are you? He's gone. He's gone? All right. Well, he was not born when I was working on this thing. And I was just saying, yeah, the first version of Linux I've read the whole source for the kernel. And you can't do that anymore. But you could back then. So I tried to, I participated in a number of projects. The first one was, we tried to clone the Windows system. So we tried to bring Windows to Linux. That was called Wine, and I worked on that for a while. I worked on the Linux kernel in a misguided attempt. I thought that the future of the world was going to be workstations, in particular Spark workstations. You don't know this, but these were different CPUs, different architectures. They were big, expensive machines. And I thought the world was going to use that. And then one friend told me, what are you talking about? Intel is getting cheaper. This is nonsense. So he taught me some sense. But it tells you just what the kind of mistakes that you make as a young person. You just don't understand some basic stuff. And somebody just, somebody 10 years old that tells you, what are you talking about? I was like, oh, all right, that makes no fucking sense. So the other thing that I did is this file manager. This file manager was written initially in 1992, and I still use it to this very day. I probably have 5 or 6 versions of this thing running at any given time on my machine. I cannot work without this thing. It is a clone of an even older program for another operating system called DOS. It's called the Minion Commander. Like I said, I tried to destroy Microsoft again. I tried to replicate Windows, and This project eventually went to a lot of places. I only contributed the very early days. I didn't stick around with the project. We thought that there were better things to do. And actually today, this project, I don't know if you know this, but this is what powers Steam on the Linux platform. So if you use Steam, I think there's probably one line of code or one semicolon still left from when I contributed. Not much really. Can I go to the next slide?
Let me change focus.
Go ahead.
Oh, thank you.
You have to ask for permission.
Now, the big challenge that we had with Linux in the day, the reason why I was working on the Wine emulator is because Linux had no applications. We had nothing. So, but Linux had a couple of nice capabilities that Windows didn't have. We had multitasking. When your application crashed, you didn't bring down the machine, right? So back in the day, if you made a mistake, and you made what we call now a seg fault or a null reference, your whole machine would crash and you need to turn it on and off. And usually, the machine that I was using at the time was a IBM PS2. It would take about 2 minutes to boot back up, right? So every time you make a mistake, it's 2 minutes of wait, right? I know this sounds primitive, and it was. And Linux, on the other hand, didn't have this. If you crashed, it would just generate a core dump, and you could keep going. So I had seen the feature. Not only was this open source, was free. It didn't have a networking stack, but at least it didn't crash. And we didn't have apps. You have to remember, Microsoft had Office and Excel, and there are hundreds of games. So that's why we wanted to bring Windows, an emulator to Windows, to Linux. That's the origin of the Wine project. Bring applications to, bring all those applications to Linux. And that's why I worked on that. Then we figured, you know what? Java is a future. Java came out around this time. There was a fabulous system. I know. I saw your face. I saw your face. But you have to realize that in this point in time, the only thing that you could use that was suitable for writing code was C. And C++, you have to remember this. C++ was in version 1 and didn't quite work. In fact, there's a story on the Unix Haters Handbook that says, sometimes when I read the spec and it wasn't clear what the compiler was supposed to do, I would write a test case and feed it to the compiler to see what it did. And more often than not, it just crashed. This is the state of the world in this era. So Java comes out and it is a good language. It is a good language. Don't do not move. So we worked on a clone of Java, but it turns out that there was not a lot of interest in cloning Java to be fully open source, because Sun was giving away a free version, right? It was free without the source code. So many people are like, people that didn't have an ideology or principles like me. Those people were just happy to use the free version without knowing that the man was hurting them. So we couldn't really build a momentum around Java because there was a free version that you could use. So that kind of effort sort of flopped. And the effort kept going for a few years, but it really failed to gain traction. We really couldn't get any traction for this. There was a VM called Café. We attempted to clone that UI that you see there. It was called AWT. We tried to clone it. It was incredibly difficult with a toolkit called Bliss. We couldn't really get far. Not many contributors. Very difficult. As opposed to the first thing that I show you, the Midnight Commander, that thing. So what is interesting about this file manager that you see right there is that once I open sourced this thing, there were 3 students from this university that joined the effort. And it was amazing because I didn't write the whole thing. There were these kids from the university that were contributing and sending code. I'm still working with one of them today. In fact, we were just with him a few minutes ago. Radek Dulik, Pavel Maciek, who went on to work on the Linux kernel, and Jacek Jelinek. So this thing is actually work of collaboration of many people, and they were some of the very early contributors. And this little piece of, piece of file manager, we ended up, by the time I left the project, we probably had some 25 contributors, very active contributors. And on the other hand, the Java one, we could only get like 5. So it was very disappointing. Then in 1997, after Windows 95 comes out, this is the first version of Windows that doesn't absolutely stink, right? So it has a good UI, it's still crashy, it's still unreliable, it's still not good, but it's very pretty. And we already are feeling horrible because the word processors of the era are just absolutely terrible. We have nothing. I mean, on Linux, you know, our excuse at the day is we don't need Word, we have TeX. You know TeX? I don't know how to pronounce it. You know, we use TeX, it's better. You know, you describe your intent, right? Anybody that doesn't describe intent is an idiot. So, you know, we said things like that, and you don't really need spreadsheets, you write Python programs or Perl, whatever was available at the time. We eventually, there's a long story, I'm not going to go through the whole detail, but we launched an effort called the GNOME Desktop in 1997 to compete with Windows, and it was beautiful. And it brought a lot of innovation, as you can see. The first thing is, we made the bottom thing of the screen, the panel, which is the launcher, you could add these thing called applets, and there were little programs, right? So, for example, that little guy there that has the envelope would show you how to email, and you'd show you the time. The next one, I don't know what the next one is. The third one is a fish. It was called Wanda, and all it did is just be a fish. So it just won. That's all it did. You could keep track of your memory usage. You could keep track of, that was a music player. So all of those things were embedded. The other ones were launchers. And when we built the file manager, we built it in conjunction with a community of graphic designers. You might have heard of it, the GIMP community. It's a paint program for Unix. So the people that came out of the GIMP community drew all those icons that you see at the bottom. And they had run that foot. And we didn't know what to do with the foot. But we also didn't have a logo for the project. So the foot became the logo because that was the only icon left. So that's the story of the GNOME Desktop logo. Then we had another problem. The one thing that you see on the top, that's a file manager for GNOME. That is a file manager for GNOME. And what is interesting about that thing is I needed a bunch of icons. I needed icons to describe executables, documents, programs, spreadsheets, all those things. Icons for everything, devices and so on. And I couldn't convince the designers to give me any more icons, right? Nobody, I mean, at least 1997, nobody draws, right? And so we were using that piston for libraries. You can see the piston right there, the one that says LD-207SO. And I couldn't get any more icons, so I drew those things by hand. The SL, it stands for symbolic link. So for anything I didn't have things, I just drew symbolic link, devices were /dev, just like that. And that was the file manager for about a week until the artist saw this. And they said, okay, I'm gonna take some time off this week and I'll get you some icons. Now, as you can see, the aesthetic, this is the very early days of GNOME. We didn't really have good taste. It was bad. Now, if you actually Google GNOME 1.0 and you find the pictures, there's a lot of other very interesting things that you'll see. I mean, I picked the most decent looking one. But you could style every element of the UI with bitmaps that could stretch. So it was intense. It was good. A part of me still misses those days. But we built a lot of applications for the desktop, and we were building them on C and C++. And the reality is that we built them in those languages because, not because we like them, but because you have to understand that in this time frame, 1997, running scripting languages was very expensive. So we really believed that writing code as a low-level language was a terrible idea, right? It's inefficient, it's slow, it's error-prone, it crashes. So we wanted to use a high-level language, and we tried. In fact, if you go back to the original announcement of GNOME, the whole purpose was to write the desktop in Lisp, because that's the kind of shit that you believe when you're that age. And we tried Lisp, it was too slow. We tried Python, it was too slow. We tried Perl, it was too slow. So we couldn't use any of those things. Yeah, this is the kind of machine that we developed. When I built a spreadsheet for this thing, I had 8 megs of RAM. So it was not happy time. So we had to write code in C and C++. So it was incredibly buggy. So there was a little icon it was the equivalent of an emoji these days with a guy just going. And it was the icon that we used for core dumps. right? Which is the file that is generated when the program crashes. So you spend most of, I mean, GNOME was a nice desktop and you would use it, but most of the time you're just writing those core dumps everywhere all the time because everyone in the file system would just be dragging those to the trash can. Then I built this spreadsheet because, of course, I'm trying to destroy Microsoft. So I built a competitor to Excel, and I built a spreadsheet that actually has better math than Excel to this day. So I'm not allowed to contribute to it anymore because actually this is my spreadsheet. I'm very proud of it. And there were a lot of contributors again. A lot of people contributed to this effort. Somebody from the UK contributed all the Excel import-export functionality. He went on to be the leader of LibreOffice. So if you use LibreOffice today, he's the same guy that worked on this. We got a Danish mathematician to contribute all the statistical functions in Gnumeric, which is why Gnumeric does statistics properly. If you're a statistician, you know that Excel actually does it wrong. So, yes?
So we have trouble with the live streaming. We need to restart the machine. Would you mind pausing a bit? And
no, I'll keep talking. It doesn't matter. Well, they'll miss a bit of history, but let's not worry.
Right.
So reboot the machine. Oh, I'm not going to have slides.
yeah.
Well, I can tell you something else in the meantime. So, sorry. Do you have any questions? Let's do that instead. Okay. So what happened next? Do I get my slides back?
Yes. It's all yours.
And mine? All right. So we had that company. And eventually, the nice thing about having proprietary software we learned is that because people cannot get it unless they pay you. This is our Outlook client, right? Again, trying to destroy Microsoft. And we built more proprietary software. I mean, once I was in bad terms with Richard Stallman, we did all kinds of things to keep our people employed, right? It's emotionally very difficult to lay off your friends, and at this point we're probably 30, 40 people. So we did more proprietary software. So we trained our ideals and principles every day of the week. And we ended up building enough software that a company bought us. But before that, we also negotiated with Office, with Sun. Sun had an office suite called StarOffice, and we came to an agreement. They would kill their email product, and they would advance Evolution, which was our Outlook clone. And in exchange, we would kill our spreadsheet and the word processor that the GNOME project had done. But they were open source, so they never really died. You can't really kill open source. It kept going. But at least we were not going to work on that thing. So we joined forces with Sun, and we launched the OpenOffice project. And one of our employees, Michael Mix, became the lead of OpenOffice and eventually became the lead of LibreOffice. He's the guy that we should thank for all of that work. And in 2001, so this is before we actually have to do proprietary software, we realized Microsoft releases this thing, the .NET platform, and this is why we're here. They released the .NET platform and the documentation, and it turns out that they have a really nice language. It's called C#. It's a little bit better than Java. I hope you're happy. And it's a little bit better than Java. You know, it has all these things that are fixed. It has a very nice interrupt story. You can call C libraries because all of GNOME is written in C. But it only works on Windows. So of course, because we are very young and dumb and we don't know what we're doing, we said, let's clone this thing. It's easy. How long can it take? 6 months tops. So I started working on that. We're still working on this. So we launched Mono as a means to an end, right? This is the technology we've been waiting for, right? It can be compiled, it can be fast, We looked at it on Windows. It was decent enough. How hard can it be to write a garbage collector? Or a git compiler? Easy peasy. So we launched this thing, and it was fantastic. So we sold our company and developed our company. We're very happy because there was no pressure to do anything else. But what was nice is that we actually delivered on the promise of using Mono to build desktop applications for Linux. It was very difficult with these apps, and we had a massive amount of apps on Linux. I counted 6. Actually, there's another one that I counted the other day. 7. We had 7 apps. This was big news. We were, I mean, my God. This was amazing. That thing is a UI designer, Glade. The thing on top is Banshee, the music player. I'm still working with the guy that did that designer. And that, in fact, is mono-developed. I'm still working with that guy, the guy that did the music player, Aaron Boffer. The guy on the bottom is Luis Sanchez. This thing was Beagle. That trader went to work for a company called Fastly. And F-Spot was built by Ettore Perazzoli, long story, and Larry Ewing. And Larry Ewing is the guy that does .NET for WebAssembly. So I'm still working with these dudes after 19 years. And it was massive. We had 6 big apps. And in 2007, we realized that there were more Silverlight apps than we had desktop apps. So we said, easy, all we have to do is clone Silverlight. Again, this is what happens when you don't have a mentor. You do these things. And so we cloned Silverlight, and we got a collaboration with Microsoft going, where they would give us APIs, and they would give us API documentation and test suites to make this thing work. And it was actually a great, collaboration. I'm really happy about that. And then something amazing happened. Apple releases the iPhone, which is the most amazing piece of technology in the world. Who has an iPhone here? Proud people. What about the rest of you? So I see this is how it's in East Europe. I'm kidding. No, but what happened is that Apple launched this thing. Apple launched the iPhone, and it was incredible. And we got Mono running on the iPhone. And then this company, this was a company called Unity. And these dudes were a company of 5 or 6 people. They were a tiny little shop. They were building a game engine for the Mac. And one year, the last time I saw them, they had a tiny little booth that was like this big. It was not very big. And then the iPhone came out. So it was GDC in March. They had this thing. Then the iPhone comes out, and they asked us, "Can you port it to the iPhone?" We had a port to the iPhone. And then Apple changed the rules, and they said you can't generate code dynamically. So we had to scramble and put all kinds of hacks on Mono, so we could run on a device that didn't allow JIT compilation. And this was the point where the company had invested all the resources. It's a tiny company. They're about to go out of business, right? They put all their efforts in this basket. But we managed to get it out, and we gave them Mono for Unity. And this thing started to sell like hotcakes. So by next March, the next GDC conference, the Game Developer Conference, they had gone to a booth that was twice the size of this room. It was massive. Unity was everywhere. People were buying this left and right. And they were going to introduce the Android product next, and then support for more consoles. But this is what launched Unity. The iPhone launched Unity. Without the iPhone, there would be no Unity. And it was just fantastic. This thing was incredible. So we realized, maybe there's something on this App Store thing. So we went and built our own product. It's not a game engine. It was for building business applications. And we put .NET, well, since we have .NET on the phone, we might as well give it called .NET for business apps. So that's what we did. We did this at a company called Novell. And then there's a very interesting phenomenon that happens in capitalist societies. You might not know this because you're noobs, but there's this phenomenon where the public value of a company, which is the value per share multiplied by the number of shares, right? The value, the market cap value, falls below your assets, right? So your assets are like your building, your computers, how many cars you have. These are your assets, or how much money you have in the bank. And usually the market cap of your company tends to be above this thing. But there's this phenomenon that happens when the market stops believing in you and you drop below your assets. This has happened to a couple of airline companies. I don't know if you know this, but some airlines are worth less than the actual value of the planes they own. So what happens? Well, in capitalist America, somebody with money comes in, buys your company, and sells the assets and destroys the company. It's a win-win. No. Well, somebody wins. And so this happened to Novell, my previous employer. The value of the company dropped below this very, very dangerous point. You don't want to go below this point. So you come to this point. So they essentially sold all the assets. They sold the patents. They sold all kinds of things. And they didn't need the people to maintain the product. So they laid off on the first day 1,000 people. And I was one of those 1,000 people. So, and at this point, I have to fire my friends again, right? So they say, hey, listen, we need to have a meeting. It's like, perfect, I'm excited. I think we have a plan for the mobile technology. We're going to go forward. I was like, no, listen, I need you to fire all your friends. So here are the packages. It would be great if we can get it done tomorrow. All right, okay. And then it's like, all right, I got it done. It's like, and now you're fired. So like, all right, okay, so see you later. So, but you know, we have tasted the sweet proprietary revenue, and this product was fully proprietary, and we decided we're going to rebuild it from the ground up, and we started rebuilding it. But then somebody at Microsoft came to our help. A guy called Brian Goldfarb caused a lot of trouble to the new owners of Novell and said, hey, listen, I know we have a partnership, but unless you help these guys start up and license the deal, we're going to have to cancel the contract. So this forced the hand of Novell, and they had to negotiate with us to salvage the product. So we ended up licensing the product from Novell. They gave us the right to license all the technology, and we started our company in 2011. We hired back all of our friends. So our friends were out of a job for about 2 months before we could get them back in. Also, thank you to European regulations, Novell could not fire the Europeans at the same time. So Americans, easy. Like I said, I showed up one day, it's like, here's a stack of 20 documents, you gotta fire your friend, and then you fire. And this was the problem, because now they couldn't fire some Europeans because the boss was gone, and I wasn't. So they couldn't fire some of them in some countries. The French guy took like 6 months to fire. The German, the UK guy was working for them for a year before they realized the guy was not even working. I mean, it was so European protections are actually quite good. So as our revenue was coming up and they were firing people, we were able to bring them on board, right? So we didn't need to come up with all the money right away, right? We just needed Novell to not fire them fast enough. So thank you for the European Union. So we did that thing. It was, I have to tell you, one of the sad things about starting these companies, we tried to raise capital in Silicon Valley, and raising capital in Silicon Valley on .NET at the time was horrible. They told us, why are we going to invest money in this thing? .NET is a melting ice cube, right? Nobody uses this thing. If you're not doing JavaScript, you're dead. So it was quite scary. But we managed to find a couple of companies that believed that. So here's the interesting thing about .NET. The world was using JavaScript, but all the companies with money, the Fortune 500, were using Java or .NET, and they had money. So the interesting phenomenon that happened is that almost all the mobile companies that were doing JavaScript stuff or Lua or other stuff, all the popular stuff, they went under because they couldn't sell anything. They also made it open source. They're open state. And our stuff was proprietary, very expensive, and we sold to the Fortune 500. So we were printing money. Oh my God, it was beautiful. It was so beautiful. So every day I grew a little bit closer to Steve Ballmer, but I still hated him. And we started a collaboration. There was this dude that our board of directors knew, Satya Nadella. They sat together on boards, and they introduced us. So Satya brought us in and said, let's have a partnership. So we worked together in a partnership with them. This is 20 years after I started to try to destroy Microsoft. And it actually was a very fruitful collaboration. And then Ballmer resigned. What happened? I don't know where he resigned. What did he do? He did something wrong. Anyways, Ballmer did
price.
What?
The stock price.
The stock tank. Perfect. Yeah, you can say a lot of awful things. Like, what was the thing that the Uber guy said? Did you see what the Uber guy said last week? Did you see this?
Yeah, but I've already forgotten.
Did you guys see what he did? Oh, it's amazing. They're interviewing the guy. It's like, hey. Oh, yeah. Hey, some people on your board of directors are the Saudis, and the Saudis just went and killed a journalist. Now, I don't know if you know the details, but they didn't just kill him. They got him to the embassy, and then they used a machete, or whatever they use in Saudi Arabia, and they cut him up in pieces. And then they diluted the bones and they put it in the trash, and it was very grotesque, right? And the Uber CEO says, well, you know, the Saudis make mistakes, you know, we make mistakes. Right, so this is a different, you know, in America, it's okay if, if your partner is killing journalists, that's fine, but don't let the stock price drop. So anyways, Satya Nadella, and then magic happens. They appoint Satya Nadella, the CEO of Microsoft, and they start to change. So Satya Nadella has a very different outlook on the world. And I'm no longer, a purist. I've come to terms, so I have a little bit of, 50% open source, 50% proprietary, and Microsoft's all proprietary, and Microsoft starts to move towards the center, right? They did that announcement. Microsoft loves Linux. They embrace Linux on Azure. And then they announced that .NET Core was open source. So all these things that for years we've been fighting, we need open source .NET, they were starting to happen. So Ballmer did all of this stuff, and we kind of started liking Microsoft. And we started working with all of our Microsoft friends. When .NET Core is open source, we started interacting with engineers. Before, we only interacted with PMs. And this is the first time that we started interacting with actual software engineers, people like Carol, in the open. And then they acquired us, and nothing makes a man happier than being acquired. But here's one thing that happened. You have to remember, our product was very expensive. We were selling licenses for $2,000 a piece. Right, so if you wanted to use our product, $2,000 per person. And then Microsoft does the exact opposite of what we were doing. They said, you know what, we're just going to open source all your stuff. So they opened it all up. So it made me feel a little bit happy. It's like, now I can actually pretend that I only care about open source. So I get paid for it. I think the bottom line is, if you're going to do open source, you need to find something that finances you. You need a patron of the arts, if you will. These days, Microsoft's a very different company. As you know, we now go wherever you go. So we actually we're not very religious about our languages. In fact, we just announced that we're going to support Java. Java was a language that Microsoft fought and they went to court for many years ago. We'll support you in Python, we'll support you in C++, we'll support you in Java, we support your Python. That's only our group, our developer division group will support all of these languages. We wish we could add more languages, but it's just a matter of time. Microsoft is, TypeScript is probably one of the biggest gifts to humanity, right? Because JavaScript is a piece of very interesting technology with a number of flaws. And TypeScript essentially fixes all those flaws, and I think that it's made the web a lot better. But also, it just shows you how far the company is willing to go when they kill their whole web browser and they say, you know what, Chrome has won, let's use the Chromium engine and let's embrace this. But beyond the technology, I don't know if you've seen that there used to be this picture of how companies work, and it's all little hands, right? It's like Google is top down, and Facebook is, I don't know what it is, and there's a bunch of companies. But Microsoft is different divisions pointing guns at each other, right? And so when Satya comes in, you have a company that is fairly antagonistic between the groups. And what they need to do is change the company. And what is very interesting is I joined, this already happened, it started happening, but I joined as they were rolling out a number of these initiatives. I think it's in the next one. But when I joined, they were rolling those initiatives, and ever since I've been there, they keep rolling out these things. So let me tell you, for example, we're just going through a whole company training program. So we're going to train 140,000 people. Have you taken the training yet? The values?
Yeah.
So, so we're going to
manager, come on.
the what?
I'm manager.
So we're going. It's accountability, respect, and it's not indifference. That's it. No.
Inclusion.
No, it's not inclusion. I forgot it. And I thought, of course. Anyway. But we're essentially saying, no, guys, we're not going to get culture, we're not going to get a better company just by saying that we're a better company. So there's actually top-down mandates to train the entire workforce. Training the managers, changing the values, making sure that we respect the laws, making sure that, so it's no longer the Microsoft that would go out to the market and destroy its tenant. They want to get your bonus, that's what they're going to measure you on. They want to know that as you work during the year, that you help others, that instead of inventing your own thing, that you show that you use somebody else's work, right? What's the third one? You're the manager. Building the success of others, help others succeed, and deliver results. So those are the three things. And this year they said, you better give me a good reason to be a diverse company. So now we're a company that believes very strongly that we're going to build better products if we have different viewpoints and we have employees from different backgrounds, different genders, different ethnicities, different countries, and we're trying to become a more distributed company, which is why we're hiring in Prague, right? Among other things. So, anyways, this is my story of how I ended up at Microsoft. I think that I just want to close that this is still not a perfect company, but I like that the company knows this and that they're continually trying to help us and we're trying to fix our problems as humans. Now, you don't know this, but in America it's been a couple of horrible years with Trump in the administration. And it shows the worst of what humanity can be. Maybe not the worst, but a path to worse. The worst things of humanity. And being in a company where we're actually working against those things and we're trying to help people be different is very good. So, thank you very much. Are we on?
So what do I use to flip the slides?
Who is the quicker?
Is that right there?
Yes.
Is that gonna work? Okay. Should work. All right. So as Carol said, I'm Jared Parsons. I'm the C# dev lead on the compiler team. And first I'm kind of curious, how many of you guys have used C#? You guys use, okay. Oh, okay, wow, this is great. So this time wasn't even that necessary. So C#, it's a general purpose. Can I switch this over so I can see the slides? There we go. Awesome. All right. So C#, it's a general purpose programming language. It has some object-oriented roots, as Miguel said. It was invented around the time of Java. If you go back to C# 1.0 and you knew Java, you could pretty much pick up C# in about a day or two. But C# is also about 20 years old now. And it's, at this point, kind of a true multi-paradigm language. So we've kind of added lambdas, like a lot of functional roots with kind of lambda expressions. Pretty much every release of the compiler now, we add some more levels of immutability. And we're also a language that can be very focused on performance. And we have raw pointers. If you really want to embrace your C roots and shoot yourself in the foot with a pointer, C# will let you do it. If you're a more conservative person who believes in a little bit of safety, we also have managed references, which are like pointers but safe. So it's fast and it's safe, and you can't quite blow your foot off as easily. And I forgot to say, if you guys have questions during this talk, raise your hands. There was nothing I hated more than being in college when I had to like sit through like an hour-long talk from someone and I had to hold everything back to the end. So my history at Microsoft, I've been working in programming languages at Microsoft for about 13 years now. I've done about half of that in production, about half of that in research. And I'm presently, as I said, I'm the dev lead on the C# compiler team. I'm also a member of kind of the language design team. And the difference between those two roles is the compiler team, we're there to actually produce a product that customers can use. We ship the compiler out to everyone here. The language design team, though, that's the team that kind of sits down and says, like, what are the features are we going to do? What's kind of the direction of the language that we're going to pick for this release? And I was lucky enough in some of my research to actually have a paper published. And this was one where we actually took a lot of time to add essentially permissions to types, where you can basically take a type and you can have a readable version of the type, you can have a writable version of the type, or an immutable version if you're a truly good programmer. And so that was a lot of fun. I had a PhD student who wrote the entire paper for us. I got to put my name on it, and we got it submitted to the OOPSLA conference. So my academic background, I attended Georgia Tech, go Jackets. I have a bachelor's degree in computer science. I graduated in 2004, so now you know how old I am. And my kind of specialties was networking and compilers. And during my time in college, I spent about 2 years as a teaching assistant for Intro to Programming, and the other 2 years in the Intro to Compilers class. So some of you may kind of like put these slides together and say, okay, so this guy was like really into compilers in college. He even taught the Intro to Compilers class. He's been working in programming languages for about 13 years now. Like, man, he joined Microsoft and he lucked into that job that he wanted. But I have a small confession to make. When I left college, I hated compilers. I hated them so much. When I filled out my application for Microsoft, and they had this beautiful section of what are your interests? Where do you want to work? I found the compiler box and the JavaScript box, and I checked everything else. And Microsoft kindly rewarded me they stuck me in the developer division. In the developer division, that's where we build all of the tools. That's where we build compilers. We build Visual Studio. And I saw that and I was a little disheartened, but I found out I wasn't on a compiler team, so my day got a little bit brighter. Eventually, though, and part of the reason like I kind of hated this is when I left college, there were certain phrases I just never wanted to hear again. LL versus LR, LL1 versus LLK. I actually had to look this up for the talk. I couldn't remember what that was. So context-free grammars versus regexes, shift-reduce errors, reduce errors, if you guys still use YAP. Reduce errors ended so many of my Friday nights. And could you please provide a formal proof that 7 is odd? These were all things that I just kind of wanted to end. But I ended up working in languages for 3 really important reasons. One, I did not like the job I had at all. I think the thing we built was something like we were producing an XML schema. It was and I couldn't really understand what the customer was. And importantly, I knew what a compiler was. I could understand the customer and the product I'd be delivering. And my boss, who I started working for at Microsoft, who I really enjoyed working for, she had moved from the team I was on to the compilers team. And I was like, well, you know, I really liked working for Julia. I kind of know what a compiler is. I'm not happy with my job. Can it really be any worse? And the funny story is the person I was working for, Julia, she's now actually the corporate vice president of DevDev. So apparently a lot of people liked working for her. But it turns out when I went to the new team, I love languages. And that is what I am passionate about. And you might be wondering, like, what's the difference between a compiler and a language? So compiler is a tool that will take source code and turn it into an executable if you're lucky. And I kind of found that for me, like when I was in the compilers classes, like we ended up focusing on like what are the optimizations, what are some of the weird grammars that we're using, and it really felt like this static, boring thing. But languages, like at Microsoft when I was working these production compilers, it's all about the developer experience. If you have a programming language and the only tool you have on top of it is a compiler, that is called a toy. Like a programming language is about the experience. It's about the set of tools that kind of developers use to make their life more productive. And so that can be anything from the compilers, the Visual Studio when you code in, buggers, IntelliSense, all of it. And what's also really awesome is when you work on a language, your customers are developers. And developers are a lot of fun to talk to. It reminds me of being in college. Like, you're talking to someone who speaks the same language. They send us bug reports, they tell us, like, where are we having performance problems? And every time we get a view into, like, what are you working on? Talk to me about the code you're writing. Talk to me about the scenario you're solving. And so it's a constant way to keep yourself fresh and kind of abreast of the world. Now, I don't want to completely bash like my time at university, because university, what it did was it kind of gave me the tools to reason about programs. Like it taught me about syntax, grammars. I know I bashed context-free grammars a minute ago, but all of those kind of like tools really helped me understand like what a program was. But working at Microsoft told me that it's a lot more about that. It's about building this experience around your language features. And it taught me to really kind of think about the customer and think about how I can use language as a tool to kind of help them with their productivity problems. It's like, show me all the code you're writing, show me your boilerplate code. Let me figure out like what features could we build to make all of that go away and make your life simpler and more productive and push you kind of to the pit of success. Now, so I want to talk a little bit about kind of language analysis and what that means. So, as I've said a few times, like language is an experience. And besides turning source code into executable, you have to, for every feature you add to the language, you have to colorize it in Visual Studio. You have to provide diagnostics. Customers aren't going to do things correctly most of the time. And you need to have good diagnostics to tell them what they did wrong and push them to the right thing. That means you have to build tons of error recovery into the parser. We also have to work with the IDE team. Whenever we add a new feature to C#, if you notice, Visual Studio has nice, cool refactorings for it. And that's because we have to sit down with the IDE team. We have to talk about how are you going to like get the information you need to make all of these other features work. We have to get IntelliSense for guiding the developers. And we also have to think about how do we build a nice debugging and stepping experience around this. And when we kind of step back, like all of the things I've just talked about are how do we make the C# developer experience productive? How do we make the C# team productive? But when we kind of like take a little bit of a step back and look out, we find that we're not the only people who want to do this. There are other IDEs out there and other platforms that want to have the same analysis that we do. There are a bunch of people who build all these custom diagnostics engines. Like when we would look around Microsoft and people would be sending us questions about how certain parts of C# should be parsed, and we're like, why do you care about how we parse this? And they're like, oh, well, we wrote our own C# parser so that we could analyze our source code and have all these cool diagnostics. It's like, that's not great. You should use ours. And we find that people love to build source transformers, generators. There's all kinds of scripting engines you build on top of it. People build great documentation tooling on it. I don't know if you've gone to MSDN recently, but a lot of the way they generate their documentation now is actually just sucking in GitHub repos and like pulling out the documentation links to put up there. It's really awesome. And so what we kind of learn when we think about all these scenarios is that the compiler is actually an analysis engine. So the primary task of the compiler is to basically produce errors and warnings, kind of allow people to inspect symbols, like let me parse this line of code, and then I want to ask you some questions like, is this a method call? What method is this pointing to? Which overload? What conversions are you inserting under there? And under the hood, when we do this analysis, we want to have enough information so that in the rare case where the user did everything right, you can actually produce a binary and write it out to disk. And this is kind of one of the big things I learned, like one of the big differences between like college and production is in college, when you're kind of doing all your programming like tools, when you're writing your mini compilers and parsers, I bet like 99% of the time you have a functional program in front of you. But
But the reality is the overwhelming majority of code that the compiler code base sees is horribly broken. And that's because real programs, they aren't pasted in these complete perfect things. Users actually typed them out. And so, kind of as an example, is it open or, yep, there we go. Okay, is that gonna,
we can either move it or we can
just
duplicate the
move
screen.
it all. Oh, yeah, delete it, that's the whole good part. Okay, do whatever you want.
No, but if we move it there,
Okay, move it there.
you'll not see it here.
Okay, I'll turn and do some awkward typing.
Okay, that's easier.
That's good enough.
Doable? All right.
All right, am I gonna break the streaming if I turn the laptop? Oh, I thought something. Where's the mouse go? Huh? Where is it?
It's a cursor. You know what? Let's duplicate the screen.
Oh, there it is. All right. So, oops. Oh. All right. And then, since everyone has perfect vision here and can read everything. All right. How do I take numbers? 150 is all I can say.
Let's do this.
There you go. Look, type numbers. Okay, I'll just select it.
Now it's English keyboard.
Oh, that's great. That explains things. Okay, perfect. So, now, when you look at this, once again, let's talk about the simplest basic program that everyone's typed a million times before. Hello world. Now, the problem when we talk about what does the compiler see is that people type slow. And so, compilers don't see hello world, they see C. And then they see, eventually, O. And then we see this. Then we see this. And notice that for every single keystroke, we're giving you feedback. IntelliSense works on every one of these keystrokes. There's an error message under there saying something along the lines of, I don't know what C is, I don't know what con is, I know what L. And every one of these kind of intermediate states is something that the compiler has to process, it has to analyze, and it has to give good information. Because in every one of these broken states, the IDE has to remain functional. We have to essentially be able to give them enough information to provide IntelliSense. And let's say the user was actually typing above some existing code. So notice that I have console that's broken here. I'm on a completely different line. I have no semicolon. But as I start typing letters, the compiler is still helpfully giving me IntelliSense for variables that are declared way above that. And even to the point where I can take all of these broken states, and you know what? The compiler, if I hover over here, the compiler says, oh, these symbols are identical. I recognize that I can do enough error recovery to recognize that this args is that args. And if you even want to do some refactoring, the compiler is happy to keep doing this, even though, the code surrounding this is horribly broken. And when you think about console.hello world as a complete program, just typing out console right line hello world, there are about 31 different broken states and one good state. In the compiler, we have to be resilient, we have to be functional throughout all of that mess in the middle. Uh-oh. I say that a lot. Oh. Yeah, what is that? And I'll only make you do that one more time.
Thank you so much. I really appreciate it. Let's run it again. Oh. Just go to slice where. This one?
Yeah, there we go.
Let's run it.
All right. So demo Hello World. So you can say the C# dev lead came and he demoed Hello World. All right. Yeah, I need this. There we go. Perfect. And so this when for us when we were on this journey about 8 or 9 years ago before we started the Roslyn project, this kind of raised a question for us, what is the compiler? And we kind of originally started out when I worked on the compiler teams 13 years ago. that compiler was this idea where we did mostly a source to text transformation. But now we kind of more think of the compiler as it's an API for analyzing source code. It is a library, and we want a lot of people to use it. And further, we want to make sure that this is the only library in the world for analyzing like C# code. And this is not because, as Miguel would say, we want world domination or anything like that. It's just because we want to make people's lives simpler. When we started on the Roslyn project, we kind of, I can't remember how many C# parsers, how many different C# parsers we found in Microsoft, but it was somewhere in the teens, where people had taken all this time to write a parser to do this crazy proprietary thing, and it's like, every time we do a new feature, your guys' life gets worse. It's like, why don't we write a really good parser, we'll put an API around it, and then you guys can use it too. So the compiler team now, the team that I run, we primarily think of our product as a library. It's a library for code analysis. We have parse trees, we have methods for symbol analysis, you can actually get flow information, you can open up a method, you can say, talk to me about where are all the basic blocks, what's the control flow. And it provides a basic model for compilation. So the actual compiler, like csc.exe, is just one tool that uses this library, and it's actually quite boring. csc.exe, it's about 1,000 lines of code, whereas the rest of the C# compiler is about 600,000 lines of code. So it's this tiny, tiny tool written around this really powerful library. And when we start kind of thinking about the library, there's actually a kind of a bit of dichotomy that we went over a little bit, where the compiler and the IDE, the two biggest consumers of this analysis engine, they actually are very different. The compiler wants to be batch throughput. I'm going to read a source file one time, exactly once. I'm going to do some transformations, and I'm going to give the customer some errors. I'm not going to give them a binary. Whereas the IDE, it does a very incremental set of parsing. Every time you hit a keystroke in Visual Studio, we have to generate a new parse tree. If we were completing if we were reparsing from scratch every single time, that would waste a lot of memory. The compiler is also very concerned with throughput. If I hit build, how long is it between when I hit build until when you can produce a binary? Whereas the IDE is all about how fast can I display IntelliSense. I almost never compile a program. I want to make sure that the analysis and the diagnostics, they come back up extremely quick. And as I've gone over before, the compiler always sees correct code, where the IDE just always sees terrible code. And the compiler is kind of there to stop people from doing bad things. That's why you're using C# instead of C. If you wanted to write terrible code with no rules, you would use C or JavaScript. But C# is there to say, like, there are good ways to do things and bad ways to do things. And what the IDE's job is to do, it's not to prevent badness, it's to actually enable goodness. They want to show refactorings. They want to give you tooltips to say, hey, you did it this way. Here's a better way to do it. Use this new feature, do this thing which is going to be faster. The compiler is very reactive, and the IDE tries to be predictive. It wants to show you IntelliSense, for instance, one of the biggest features we have there. Now, there we go. So one of our I want to dive a little bit into the API a bit. So kind of one of the biggest things we produce here are our syntax trees. And so the syntax trees, they are actually a literal representation of the C# spec. If you pick up the C# spec and you read, like, what is a statement, what is an if, you will actually see that we have a syntax node that completely replicates the spec. And we think of it as almost like a literal invocation of it. So, and the thing about our syntax trees that we produce is they're fully round-trippable. And that means that if you take a C# file and you parse it with our API, you can then write it back to disk with completely equal to the one you read. And this is extremely important for IDE scenarios because they are constantly parsing, making changes, and spitting code back out. And it's incredibly important that be exactly the same. And we are so paranoid about this that our parser actually has an if debug in it. And basically, whenever you run the compiler in debug mode and you parse a file, it will then immediately take that file, write the string back out, and guarantee that the inputs and the outputs are exactly equal. And that means every time we do a parse in our unit test and every time we do a parse when we're compiling ourselves, we do take really crazy means to make sure that we maintain this invariant. So The syntax trees are also immutable. So once you have a syntax tree, if you want to change it, it's basically like an immutable, it's a simple immutable data structure. You'll get a new syntax tree, and the old one will be preserved exactly as it used to be. And so, in addition to being immutable, it's context aware, which means we have parent pointers and absolute positions. So we have an immutable data structure that is both downward facing and upward facing, and it's incremental. How would we do something like that? I don't know how much do you guys use immutable data structures? Raise your hand if you've had to do them in your coursework here. 1, 2, oh, so half of you. So half of you probably wondering like how the immutability and the parent pointer problem seems a bit counterintuitive. And the way that we do this is our data structures are actually what we refer to them are parse trees as red-green trees. Now, if you actually go read the APIs, this slide does red, green, and backwards, but it's just fine for this presentation. So, our red trees, what we have is a simple downward-facing model. And all these red trees, what they do is they preserve essentially tokens. It wants to know what is the text of this element and how wide is it? What's the text of this element, how wide is it, and does it have any children? And the good news about these trees is they're actually highly cacheable. So for instance, if you have like x times x equals x times x, we will actually only create one red node for x. We will say, oh, there's this text called x, it has length 1, and it has no children. And then we can then reuse this red node all throughout our trees. Now, but we never, and as we basically make changes, like if you add an edit or you add a new statement, we reuse all of these nodes as we kind of incrementally update the tree. But now, the red trees, they know text and they know width. They know nothing about position. And that is where our green trees come in. So the green trees essentially are a little bit the opposite. They know their start, they know what red tree they refer to, and they can lazily build all of their children. And essentially, you get a green tree, which is the root of a C# file. And as you start walking it, it will start building up all of its little green nodes as you're walking, setting up the parent pointers, and essentially giving us the absolute position to all of the nodes. And this works even as we make edits to the file. As we make edits, we find that the red nodes get preserved very well across edits, and we end up rebuilding the green nodes only for the positions which have changed within the file. And the result of this is we have a very fast parser that's very tolerant of incremental updates. Now, kind of digging into a couple parts of the API, like we said, we have a lexing and parsing API. We actually don't use parser generators. We actually handwrite everything because we found that can be significantly more efficient. We do have, it's very much tuned for incremental parsing. And pretty much as you're typing, we're able to reuse pretty much a good chunk of the syntax tree on every single keystroke, unless you start editing kind of method body boundaries. And at that point, we do have to rebuild a little bit more. And highly error tolerant and a lot of value placed in immutability. So we also have a semantic model. And so a semantic model is essentially name binding. Parse trees just give you a whole bunch of tokens. It gives you X. It doesn't tell you what does X mean. Does X refer to a local? Does it refer to a type? And these are kind of the questions that the semantic model can answer. You can give it a node and say, give me back a symbol. Tell me about it. And our semantic model, and the workspace model, which we build on top of that, this is essentially kind of where it starts to get functional. It's more like a project system. A workspace essentially has a set of documents, a set of references, and a set of arguments that are combined into projects, and a workspace has a collection of those projects. Very much like a Visual Studio solution, not a coincidence at all. And from there, you can do things like ask the workspace, can you build this project? Can you do a refactoring across all of these nodes? Or can you do some classification? And also, it is mutable. And so one of the big themes in our APIs is that you're going to see that pretty much everything we build is immutable. And that's because it's designed for sharing. Many of our analysis tools all run in the same product. Like, for instance, Visual Studio. In Visual Studio, you're going to have the C# IDE. You're going to have a lot of analysis being run by other Microsoft teams that don't work for C#. And we have a ton of third-party analyzers running. And if you just look at the compiler itself, we have both the compiler analysis running and a bunch of third-party analyzers. And ideally, every one of these tools shouldn't be reparsing the file. We shouldn't say every time we add a tool to Visual Studio, that's another parse of C#, another round of semantic binding, another round of analysis. We want to essentially do one parse, one bind, and then share all the output with all of these different tools. And that kind of raises a question though, like how do you design an API where I can share with all these different people, but I got to make sure that when that person gets a hold of the API, they don't call delete on it, or they don't like rename some stuff that this guy wasn't expecting. And the easiest way to share data amongst a lot of consumers without making sure that one can't stomp on the other is to make it immutable. Sharing out immutable data is very simple. You can't change it. So I can give it to you all you want. So the best part about having kind of an API mentality in the compiler and saying that we're going to build a library and we want people to use it is that people will actually use it and they will build products on top of it. And this is kind of just a list of products, like off the top of my head, that people have built using our API. So SharpLab, I'm going to show you in just a second. We just started releasing Try.net. And Try.net is essentially, basically, that is what MSD and documentation is being built on now. They are, all these new products and APIs out there are putting little samples in their documentation, and they're using Try.net to run them on in the SDN. So as you look at these new pages for APIs, you'll see samples, you can interact with them, you can look at the results. We've also had a number of customers out there who have built all of these analysis libraries for C#. One in particular wrote this tool. In C# 7.2, we introduced a whole lot of new things around structs. We have ref structs, read-only structs, a ton more ref returns. And we had a customer who went out there and wrote an analyzer library, which was essentially a best practice library, saying, I'm going to flag all the incorrect uses of this feature so that people can fix them. And then because I hate myself, I took that tool and ran it on the compiler. And we had some problems. Only like 100 violations that I'm currently trying to work myself through. All right, now we're going to have to do the bad thing again.
Let's do it.
Okay, apologies for people on the stream. We'll black it out again. We'll be back soon, hopefully. No
Just web browser.
You want the browser?
Yeah.
Sure. And this one.
Perfect.
All yours.
Oh, this is edgy. How do I zoom? There we go. Is that going to work? So, oops. Did you reset the keyboard?
Let's start with
Perfect. So, is this? There we go. So, SharpLab. So, what we have here is SharpLab. So, this is a tool. So, this is a tool for essentially where it's running C# in the browser and allows us to do all kinds of fun experiments with it. And mind you, this is all built using an API that we designed to make this beautiful desktop app and a desktop suite of tools working. And what this tool will do is essentially allow you to use C# in the browser. So you can essentially type just so you win the Visual Studio ID. You get similar forms of IntelliSense. And if you can spell, you can actually get compiling code. And where's the symbol? There we go. And this is like a super neat tool because both it allows us to do C# in the browser, and then after we finish C#, we can do all kinds of things like look at the IL. We can look at the JIT ASM if you're a true performance person and you want to see like what will this actually produce as assembly. You can run it, or like I said in Rosin, we have a very fluid syntax tree model. You can actually use this as a tool to explore our own API because I can essentially do the syntax tree mode, and as I move my cursor on the right here, you can see that SharpLab actually highlighting the appropriate syntax elements on the left-hand side over there. Now, and what's really cool about this is the way that this tool works is when he started SharpLab, he was actually grabbing the compiler GitHub repository and building it every day and then putting new binaries up. And so we actually talked to him, and I started changing how our build system works so that he could just grab binaries from us instead of rebuilding. And in repayment for us, he actually added this feature where he will essentially look at every feature branch that we're doing in C#. And if we just click on a button here and it's hopefully cached, yes, he will essentially, we can, as we're developing C# features on GitHub, we can open up SharpLab and just start looking at the IDE experience. So for instance, right now we are developing these native int types. These are ints which essentially change their size based on the platform you're running on. So if you're running on an x86 processor, it's going to run, oh no, so he is not updated, so I cannot do the demo. Unfortunate. But overall, this is a tool that we kind of put this API out there, and we never talked to this guy, Ashmine, but he built this entire product around it, and it's actually become this invaluable tool that the compiler team uses. Half the time when we're in kind of C# language design meetings, we have this web browser open so that we can explore the tools that we're building and answer like random language questions we have about like, does this work in this context or does that work in this context? It's an amazing tool, and it's like really kind of demonstrates the power of what people will do if you give them a good API. All right, now if I just hit F5, will it work? Or am I gonna breathe? Oop.
It's a process.
It's a process. Okay, that's the last one, so we won't have to do this again. Where am I? Ooh, a little over 30 minutes. Okay. I will.
Hold on. Where's the cursor? Yeah.
Perfect. There you go. All right, we're right in the same place. All right. So, I'm going to go through the rest of this a little bit quickly. I want to have a quick section about talking about how do we add features to the C# language. Essentially, how do we pick the features that we're going to do given our limited time and resources? So features kind of fall into about 3 different categories. One is developer productivity, program performance, or business initiatives. So program performance is all about like, how do I make a program faster? So some examples of that would be spanf, ref structs, ref returns, read-only struct, all my favorites. These tend to be driven by actual customer needs. So we spend a lot of time talking with the .NET product team, which we're a part of. We talk to the Visual Studio team, and we have a lot of like first-party internals. And they tend to come to us with, here are the performance problems I'm having. Here is where I have too many copies, too many allocations. And we essentially work backwards from those problems to solutions. And that is essentially where we come up with these types of features. We also have business initiatives. And I can spell amazing when I'm typing at a conference. So these are features that essentially help a greater business goal. So Microsoft tends to have big kind of overarching goals like machine learning is one, or web streaming APIs, UWP from the Win8 days. The Win8 days were like that was not always the most fun. But these are driven by the vision or company initiatives. And the way we kind of look at this is the company wants to make X like successful. How can we leverage C# to help the company meet that goal? And then there's the standard developer productivity. So these are features that make developers more productive. Iterators, link, async await. And these tend to be driven by kind of industry trends in our core language design team. Async await, for instance, was a response to the task parallel library and the fact that all of our code turned into the diagonal write code where people were writing lambdas and continue with and cancels. And link was an idea for like how can we apply SQL-like query syntax to general programming. And every release for us is kind of a balancing act. We basically consider the set of proposed features and we prioritize them. So business initiatives, they tend to kind of have highest priority. We do a lot of performance work, but it's kind of weighted on how much benefit are we going to get from doing that. And productivity, though, is like generally what we use to define a C# release. When we talk about like C# 8, we talk about non-nullable reference types. We don't talk about some of the more like esoteric performance fixes we did at the bottom to make code faster. Like when I was talking to Update today, I demoed non-nullable reference types, not, for instance, all of these tiny little fixes we did that made the whole platform faster. And then we cut a whole bunch of stuff because we always have more ideas than time. So quickly, how much time do I have? 5. Okay, we started late. Okay, then I'll ship this. Next part about shipping C#, it can be summarized really quickly. Move fast, don't break anything. Compatibility is your #1 feature. If you break compatibility, your customers will come for you. Well, actually, they'll come talk to your boss, your VP, then your VP will talk to you, and then you will decide that it really wasn't that important to fix that bug. All right. So that's it. Thank you guys very much.
Konrad. So Konrad is he's not a Microsoft employee, unlike all the previous speakers, including myself. He's actually Microsoft MVP, most valuable professional. He's part of community, and I actually found about him from his book that he wrote. Was it a year ago, roughly?
I don't remember.
You don't know, let me remember. So he has a book, and actually I saw. Are you going to talk about that, or can I? So I just saw this morning his talk at Update Conference. I stole him from Tomáš Herceg from Update Conference, and he said it nicely. Like it's just 1,000 pages, and it weighs 2 kilos. But and I admit I'm only in chapter 2. Sorry, I promised you I'm going to read it all. I don't have time, but the first 2 chapters were, I felt that I'm back at school. It was freaking amazing because there was like history. I was like, oh my gosh, this is cool. Like you learn about like how GC happens, how memory is managed like in a very nice way. It was very eye-opening for me. Not sure if you guys will appreciate it that much because you have school all the time. But for me, it was actually pretty cool, and I didn't get to the hard parts yet. I'm gonna get there, Konrad. Yeah. Anyway, and how I invited him was like, I pinged him, hey dude, I saw that you're gonna be at Update. Do you want to talk here? I was like, yeah, sure. All right. So thank you very much, Konrad. Go for it.
And congratulations, still 2 chapters is 200 pages. So. Hello everyone. As you introduced me, I'm an author of this book, and this is 1,000 pages. And when I'm showing this, it is huge. Also, it looks quite impressive. And when I'm talking about that, someone that I wrote such a big book, the very first question is always, why the hell you wrote such a big book about something which is automated, which works out of the box? Because the .NET memory management is automatic. We don't care about it, yes? And I wrote 2 kilograms about it. But still, it is so complex topic that in fact I was just limiting myself to this topic. And we will see what the second edition will bring. So, I'm author of this book because, in fact, this topic is very complex, and this memory management, automatic memory management, is in fact quite nicely but still fooling us. And this talk is about that, why we are fooled by the automatic memory management. So, just one simple slide about me. I'm author of this book. As we are speaking about it, I'm a co-founder of an initiative which is called .NETOS. I'm from Poland, in fact, not from the United States. So we are doing this in Poland. There is an initiative about .NET performance, internals, stuff like that. Also, because I have a lot of free time, obviously, I started to do a card game for .NET developers. Don't ask it. Just I feel that I need to do that for fun. I'm not working for Microsoft. I'm a freelancer, trainer, doing a lot of stuff. playing games also, because I need to write a game, so I have excuse. I need to play a game to be inspired. So, this is what I am doing on everyday basis. And this talk is about we as fooled by the memory management. There is a story. I had some friends in Poland writing games, and there is a programmer, the game developer that was on holidays, and he got an email that, okay, you did your job, you committed all your code, it was nice, but it was totally fucked. Sorry for the word. Because you used single byte as a flag for something, and you could use single bit, and you used single byte. So you are wasting megabytes of memory for us. And this developer is working for a game engine for PlayStation. So they are really trying to squeeze every byte from it because there is a limit, and they are fighting for the quality of the game engines. So obviously for game development, probably have you write something for games? Are you involved somehow in game development? Trying to be maybe. It is the world that you will be probably living if you will be writing stuff for consoles, for example. So, okay, we can say, okay, this is obvious, they have limited memory, they are fighting for performance, so this is a world in game development, but we are doing stuff for business, and business has money, so it doesn't care. Maybe. But I believe, and when I was involved in... this is a very generic slide I'm using in talks. There are no axes at the legends, there is nothing, so I can interpret how as I want. This is my interpretation for today. The green graph is a performance of the code, the availability of resources. We are having more and more memory, more and more CPU power. Everything is growing, is working faster and faster. And the red graph is about our knowledge about the stuff we are using, because everything is so free, everything is so fast, we just doesn't care. So we don't really want to know what we are using, how it is working. The whole knowledge about internals is, I don't care. Why? Why should I care? I just put it on error. It will be working fast. If it will be not working fast enough, I will just slide some option to make it faster, maybe paying a little more, but still it will be working faster. I'm quite old, so I remember this game. Maybe some of you also. Did you play that game? Did you saw that game? So some people... Good. This is a game from times which the TOS was the main operating system, and it has limitations how memory is consumed. It was a limitation of the basic memory, which was 640 kilobytes, and this game required 4 megabytes of RAM, as far as I remember. And there was a problem how to run it on, maybe it requires 8 megabytes, and I had 4 megabytes. So we need some fine tunings, for example, where to put mouse driver to have more memory for the game, or where to put music card driver. Fine-tune the configuration of the whole system. It's so-called AutoExec.bat file, which is dinosaur era of computing. But yes, so we need to run a game, we need to understand how memory is working in an operating system. Now we are just launching Steam and complaining about frame rates, maybe or maybe not, but we really don't care about how memory is working in Windows to run a game. But it was like that. So this knowledge about memory is drastically removed from our perspective. So the memory, we can say that maybe the memory just is, and we really shouldn't care about it, maybe, for some scenarios. Obviously it was not like that before, when people were just starting to use computers like this, which weighted to 2,000 kilograms, and it had memory of, as far as I remember, 500 bytes or something. So people programming such stuff were involved into really changing switches and plugging things to work together. They really need to understand the hardware, because the program was in fact the hardware. There was no distinction, there was no abstraction. They were just doing this, and then finding a bug was really finding a bug, because it was a bug in the wires somewhere. So they were debugging code by finding bugs. And so this was how it looked like. Now, obviously, everything is working out of the box. So we are just doing something, making software from some blocks, putting them together, compile, and everything is working for us. This is great. And if you look for a... Oh, I forgot that it is in Polish, but... This is a Google Trends for the memory leak phrase. And the trend is decreasing. People are just not searching for such stuff like memory, because you are using more and more managed environments as programmers. Also, more and more software is running on managed environments, so there are no memory leaks also in software, theoretically at least. So all this is really decreasing, and this is a huge achievement of the software development industry that we really don't care about. And obviously, we should probably not care. But there are some edge cases. There is a very short story about Instapaper. There's a kind of link aggregator. You can save links to watch later. Probably you won't, but at least you can save them to have it in this Instapaper repository. And they had this problem, for example, that they migrated everything to newer systems, newer applications, newer versions of everything, but they forgot about this little abstraction and the fact that the Linux file system that they were using has this limitation to 2 terabytes. It's a very simple abstraction that they forget that there exists, and after the migration everything stopped because they had bigger files. And so there is always kind of abstraction, and that is quite popular in software development, the law of leaky abstractions, coined by Joel Spolsky, which was a co-founder of Stack Overflow. The law is simple. All non-trivial abstractions will, to some degree, are leaky. We will be hit by those abstractions. They are working for us, this is good, but there are some scenarios, edge cases, and moments that the abstractions are just leaky. So we really need to understand at some point why it is not working simply. It should, it is automatic, but this abstraction is not working for me. And automatic memory management is one of those abstractions. And this is important for me because I was learning about this at school, at university, and obviously I didn't care. It was just something to pass exam and forget about it. And now I'm just discovering that, hey, it is quite wise. Maybe I should try to remember, to recall something from that, because they were talking important things, as I figured out now after years. So, yeah. For example, how the modern PC is working. We don't care. Probably, maybe if you are playing games, you know that you need a fast CPU and a lot of RAM. And this is our knowledge about how computer is working. But obviously, this is abstraction, and at some point we should try to understand how it's working. For example, there is this huge problem of the discrepancy between the speed of memory and the CPU. We are buying CPUs which have frequency of 3 gigahertz, maybe 4 gigahertz, 5 gigahertz, probably they are on the market also. But CPUs are fast, very fast. They are working every nanosecond trying to do something. But on the other hand, there is a memory, and memory is really slow in terms of how it is designed, how it is implemented currently. Memory has a frequency of a few hundred megahertz, so this is a huge difference. CPUs is always ready to do something, but it is waiting for this slow memory, which is just, we try to access something, and the CPU doesn't have nothing to do because it is waiting for the memory access. And this is a huge problem for us. And we are trying to overcome this on the hardware layer by buffering in different ways. We are trying to access more memory at a time, at once, to have this memory read in advance. And we are trying to read memory in batches. We are just doing all this DDR2, DDR3, 4, which tries to, in fact, all these solutions are around making more access at once. So this is an abstraction for us because this makes memory access not trivial, because we should not really try to access this byte from the random places from memory, because there is this cost of the buffering. We are accessing a lot of memory at once when doing something. There is also this there is a CPU and memory, but obviously this is another abstraction, because there is something in between. There is a cache on various levels. In current CPUs has a 3-level cache. So we have memory at one side, we have CPU, but then between we have 3 levels of cache, in fact. So when accessing something, we are accessing a memory through cache, not directly from memory. And moreover, it is complicated because nowadays CPUs has many cores, and cores has their own cache. As you see, level 1 and 2 caches are for each CPU core in your machine, and only level 3 is shared. So again, when I have a program that is accessing memory from the first core, the memory is cached in its cache. But in the second core is also accessing the same memory, it is cached in its own cache, level 1 or 2. So all this stuff may be problematic, because now the caches from various cores need to talk to each other to say about some changes in memory, for example. And this abstraction is hitting us because obviously the highest cache bit is the faster, and there are very big differences how fast this memory access on different levels. Obviously, access to the disk is just disaster, so we should really not try to use memory page to disk. But still, there are important differences in the performance between each of the layer of the cache. And obviously, this is very nice. We have this hardware programmer, and in between we have a lot of abstractions, and one of those very nice abstractions are our beloved frameworks. JVM, maybe not so beloved, but there is JVM. We have CLR, we have Mono, we have different managed environments. Very nice, convenient abstractions, which doesn't abstract the fact that I just described. Still there is hardware, still there is cache, still there is CPU, memory. Everything is not somehow magically covered and hidden by the runtimes. So, for example, very, very simple example of the code. We have access to two-dimensional array, and this only difference is whether we are accessing this array by rows or by columns. This is only the change in the index. And when we are accessing the memory by rows, obviously it is good for us. It is a kind of sequential access because we are taking leverage of the fact of this multiple access, buffering, reading a lot of things at once. When we are accessing by columns, most probably we are just reading something from memory and taking only a single element of it, and then throwing it away, accessing this another row to access the first element. So this is a question whether the code will be much faster. Well, maybe the difference in performance will be just not noticeable. There is a great tool for .NET, Benchmark.NET. Have you used Benchmark.NET? This is a golden standard now for measuring everything in .NET. It is all answers are there, and we can measure such code, such access to the. Something is messed with font, but at least I probably will understand here. You don't have the font installed, which I was using here. Okay, so the difference for small arrays, like array which has 15 per 15 elements, is not noticeable. It's some microseconds taken. But the bigger array is, the difference becoming more and more important for us. And the code can become times slower just because we are using this access in an optimal way, accessing only a single element from the memory, read from the memory. So very simple code. It is managed code. It is C#. It is a magic environment doing stuff for us. But still, we see this problem. We are just hitting this problem of accessing memory of different levels, accessing it from not in a batched way, with this magic of CPU and everything which is hidden in our computer. All these abstractions are just fooling us, and out of a sudden, the real hardware is popping out here with the results. Much slower code because of all of that. Another example is a problem with multi-threaded code. We love multi-threaded code because we have a lot of cores, so we need to take leverage of those cores, so we really want to write multi-threaded code. And this is C# code also that is doing things in 4 threads. We are starting here 4 threads which are modifying some array. This array is called counters here. And in fact, every thread, every of these 4 threads is increasing value on the subsequent element of the array. So the first thread is increasing the value of the first value in the array. The second thread is increasing the second value in the array, and so on. So theoretically, there is no sharing here because each thread is working on its integer, yes, because it's an array of integers. So every thread is in fact increasing its own integer. And the problem is that it is not like that, in fact, because when we are using array, array is just int array is just in memory there are just 4 arrays, one after another. And when we are doing the manipulation of these 4 subsequent integers, each core, because we can assume that when we are working on 4 threads, every thread is working on a separate core, and every core is modifying the different integer within this array. Okay, but what is not known here might be that when we are accessing memory, to take leverage of all this buffering and batch access to the memory, the internal workings of the CPU between memory and CPU is that every time we access memory, we access in fact 64 bytes. These 64 bytes are called cache line. So every time we need even single byte from memory, 1 byte from memory, the memory is written in 64 bytes batches called cache lines. So in fact, when we had such an array, this array lies in a single cache line. And these cache lines are living in the caches. So a cache of level 1, 2, 3 have no single bytes but the whole cache lines. So now we have a situation that every thread has its own version of this array in its caches. And this is a problem because now we are modifying the same cache line from 4 cores, in fact. First core is modifying the cache line, second core is modifying the same cache line, third one, fourth one, modifying the same cache line. And the problem here is that I lost the benchmark here. The problem is here that now most of the code is taken by the communication between cores to say, hey, my cache line was invalidated. You have the same cache line in your cache, so you need to read this cache line because I just modified it. And they are just talking with each other for cores invalidating their cache lines. So this is not very good from the memory perspective. The simple solution would be just to spread those integers to different cache lines. Like for example, we can create 4 times bigger array and put those integers that we are trying to modify from each core into separate arrays. And this would be a solution here. So every core will be now using the different cache line, and everyone will be happy. I just need to check. Okay, benchmarks are on the end. So this is almost working nice, because now every integer lives in its own cache line. But again, internals of .NET Framework now are popping out, because at the beginning of the array there is a length of the array. And the length of the array is used by the indexer to check when we are not going out of the range of this out of the size of this array. So there is one single one single cache line still shared between cores, because in the first cache line contains the size of the array, and the first thread will modify this cache line again and again, and the information about should be propagated to different cores. So I don't see something stopped to. I clicked something probably, and okay. Okay. So this is the case that even if we spread these integers to different cache lines, because the size of the array is 4 times bigger, the first cache line is still modified by the first core, and information about it should be propagated to different cores. So again, the solution is to move the array and create it even a little bit bigger, to have information about the length in the first cache line, and then 4 integers lying in the subsequent cache lines. So now we have 5 times bigger array to modify this. And this all is called false sharing, because in fact we tried to modify some data that theoretically was independent. It was 4 independent integers, so we should not expect any overhead of the communication between this view, any overhead of multi-threading. But because all this lives in all those cache lines, the overhead was quite big. And if we look at the performance results of that, we will see that the first code that was totally not aware of false sharing has some results, and the code that is optimized for false sharing is 8 times faster. It is totally ugly code, totally idiotic code, you could say, because it is now we are using 5 times bigger array to operate on data, but the code becomes 8 times faster. This is the place when we really get rid of every abstraction, in fact. We get rid of abstraction of framework, we get rid of abstraction of we need to get rid and understand what is underlying the fact of the abstractions of framework, of CPUs. Quite surprising thing, I believe. And here, such things will be popular in such approach, which is called data-oriented design. You probably write object-oriented code, which is very nice design. There are encapsulation, public methods, objects, references between them. It's so nice. It is aligned with every design object-oriented design pattern for sure. So we are quite happy. And then we want to write fast code, so we need to forget about all this. And then we go to the data-oriented design, which is all about how I access memory and how I should take leverage of all this abstraction, getting rid of all these abstractions. I try to understand how memory is accessed and how to design our structures to make it fast. So it is for sure not object-oriented, as you will see. So this data-oriented design will be all about how we transform data in an efficient manner. And there are very popular 2 approaches. Array of structs, which is a typical one, and struct of arrays, which is an ugly one that I will show you. Yes. Okay. So this is an object-oriented way of doing this. We have a client, we have a customer repository, which we have nicely designed customer class. It has some fields, and we have a list of customers. Everything is pretty from perspective of design, but obviously, and we have this update scoring algorithm. It is important for us. We want to make it as fast as possible. So we will be calling update scorings tremendously often for many customers, and we really want to make it really, really fast. Now it will be not. Because in fact, when we are doing something like that, it is totally mass in terms of memory access. We have a list of customers. So the list of customers inside is maintained by array of customers. In fact, it is an array of references to customers. So when we are trying to access customers one by one, in fact, we are jumping through references all over memory, from this reference to array, to this reference to a customer, to this customer, jumping all around memory in a random manner, totally mess. What we would like, and moreover, when we are using classes, they have automatic layout of fields. We are defining some fields and we totally don't care what is the layout of these fields in memory, because we should probably not care in most cases. And there is a freedom on the level of the language, of the runtime, in fact, how the fields will relate in memory. And in our case, we have this super fast algorithm that we want to use. And this algorithm is accessing some fields. It's accessing scoring field, it's accessing is smoking field, date of birth, and earnings field. So we have these 4 very important fields for us, for this algorithm. We have other fields also probably used in other cases. And what is the problem for us here is that this layout is totally a disaster from memory perspective. This object, customer, even doesn't fit into a single cache line. So when we will try to access this customer, we will need to read 2 cache lines, because of the layout of the fields is that, unfortunately, date of birth is in the second cache line. So we will need to access some data from the first cache line, which is 64 bytes, some data from the second cache line, a lot of waste of memory to get only 4 important fields for us. So it is we have here a basic benchmark of that. And the ugly solution is like that. We get rid of everything like the object-oriented approach, and we are just throwing away a customer, and now we represent list of customers as a list of their attributes, in fact. Because now we have much better data locality. Because now we have an array which represents scorings of each customer, an array which represents earnings of each customer in a subsequent way, very packed way, because now we have attribute by attribute, and we are using this array of attributes like scorings. When we read something from this array, we read it in the cache line, okay, but we are reading in fact all attributes that we need, because we need attributes for our customers, so there is no single byte wasted here in accessing attributes of this customer. Obviously it is ugly code, it is hardly maintainable code, but fast code is also quite often quite ugly, so sorry for that. This is a solution that will provide us much better performance, in fact. 10 times faster. Just code because of the reorganization of that. Because all this is is working in .NET. So all this should be maybe some automatically converted somehow, maybe. Unfortunately not. Still, we need to understand all those cache lines, all those caching, and we get a code which is 10 times faster. For me, it is quite good benefit. Now maybe I'm able to process those scorings in real time instead of doing it in hours, so benefits can be even driven by business. So this is ugly. Around this something called entity component system is built. This is tremendously popular in game development, because game development is in fact operation on a lot of objects and updating their attributes like moving objects, players, and other stuff inside the game. So around this concept, entity component system is built. I will not describe it. If you're interested, you can find Unity 3D, for example, is also moving to this very nice implementation of this. Obviously, we have this nice abstraction garbage collector. Only 1,000 pages book describes this. And again, whether it is nice, convenient abstraction or not, it is working awesome, very awesome implementation. By the way, GCPP file has only 40,000 lines of code, so it is very small file. but still it provides us some abstractions which can be leaky, which can hit us. The very could start now description of the garbage collector for a few hours, but I will not start even. The very popular example of abusing garbage collection is using string concatenation, because string concatenation uses temporary strings. When we are adding something using this, in fact we are producing a lot of temporary strings, line by line. So we have this here, a web API that is producing a lot of temporary strings, and allocations are bad because from now GC needs to maintain this and take care of those temporary strings. The solution for now, and this is always provided in every book, is to use string builder, which is buffered builder. It operates on an internal buffer instead of creating those temporary strings. And it is nice to see how it influences performance, because when I measured that, and again it is in Polish, but I will just describe it. This is a result of load test. Seen by the very nice tool which is called Performance Monitor, which is one of the ugliest tools provided by Microsoft. But they rewritten it a month ago, so I was quite surprised, but it looks now much better now. And nevertheless, this is the result of this load test. And on the left side we are seeing the result when the string concatenation version was used. And this orange pretty graph is orange, yellow, however, it's around 60%. 60% means that 60% time of the process of the CPU was spent in GC. So most of the time of the processor was taken by the GC because it was so busy reclaiming memory of those temporary strings. On the other hand, the right side is showing the string builder version when there are some spikes, but in general the average GC usage was at the level of 15 maybe. Moreover, from the perspective of the resulting throughput, we will see that the ugly string concatenation version was able to process 9 requests per second, while the buffered version with the string builder was able to process 150. So it is a tremendous difference, in fact. Both applications are working, both provide some results, the same results in fact. It is just the matter of your money, whether you want to use 1 server or 10 servers. The choice is yours. So again, this is kind of very nice, convenient abstraction of the GC, and it is working. Without measuring, we will not be aware of the fact that something like that happens. Application is working, it is consuming some Azure resources, everyone is happy. Maybe we could make it 10 times faster, but maybe you shouldn't. So, and especially that in Azure, for example, we are quite often there are plans when we are paying for gigabyte a second. It is a new unit when we are paying for a time and for memory usage. So memory usage directly translates to money, in fact, currently. So maybe sometimes it is beneficial to look at it. Yeah, so we have this law of leaky abstractions that we should really be considering. I wrote the biggest one. And at the university I hated those 1,000 books, and then I wrote one. Yeah. This is a proof. 2 kilograms and some grams. So yeah, this will be another problem, memory leak. We are just deploying something on production on Friday, very happy, everything is working, going home, and then the phone is calling that, hey, our program is taking 10 gigabytes of RAM, and we are running out of RAM, so maybe we could return from home and try to fix it. So the memory leak is another very nice way of leaking of the abstractions of the GC. Even the memory is managed, you can have memory leaks though. But it's better not to even start to describing that. So we have a lot of GCs in fact. .NET GC is quite awesome. JVM GCs are even more awesome. Unfortunately, we need to catch up them, but they have a choice of better GCs. But still, they have this same problems to some extent. Yes. Better let's skip this. And for example, JVM, when they are fine-tuning JVM for GC, they are using such magical spells copy-pasted from Stack Overflow to make, with the hope that it will make their GC more fine-tuned to the application without any understanding what all this magic means probably, but at least they have some possibilities here. So again, they have the same abstraction of garbage collection, but then some edge cases that they really need to fine-tune somehow this old stuff, even if it is working automatically. But the question is, does it have to be like that? Do we really need? But maybe garbage collection and all this automatic memory management is just a not good path. We should not follow it. Maybe there is a better solution. Maybe all this GC stuff is really not working well enough. And in case, there are some cases that they really doesn't care. Like there was a customer writing software for missiles, and they have a memory leak. I will just shortly describe it. There was this client that was writing software for how it is called in English. In general, there was a I'm searching for this word. Onboard software for a missile, and in fact the problem is that it had a memory leak, and the memory leak in a missile is probably maybe it's a problem, maybe it's not, but they calculated that most typically obviously there is a memory leak in our software, but again they added a little more memory to the missile, and then they just solved the problem, because typically the average lifetime of the missile was much shorter than the problem of the missile itself. So this is one of the solutions. We have a memory leak. Let's add more memory. Let's restart the software more frequently. There are common solutions for that. If this is satisfying us, it's okay. Some scenarios are already working. But this is quite nice idea, having no GC at all. So we are right using managed environment, and let's disable GC completely. For example, Java has this GC, which is called quite fancy name, Epsilon GC, which is all about doing nothing. It simply does not reclaim any memory. It just allows us to allocate memory, but it doesn't reclaim memory. A quite nice idea. But they have quite a lot of nice description why it could be beneficial. Like now we are doing the serverless stuff. Everyone is doing serverless stuff, short-living functions that are doing one thing and are dying. So maybe, like in case of this missile, maybe you should really not care about memory, because the processes are living so shortly that maybe all this GC stuff is just overhead, maybe. And one of the reasons for the Epsilon GC is like that. And the nice thing is that since .NET Core 2.1, we have the possibility for the very first time in the .NET ecosystem, we have possibility to change the whole GC implementation in .NET. There is no alternative currently, but of course we have this possibility. By using only single environment variable, we can change the whole GC. And I wrote such GC, which I called zero GC. Not Epsilon, maybe not so fancy name, but I wrote such GC, which is only allocating, because allocating is a very important feature of GC, so we need allocations because we need objects, but I don't reclaim memory of those objects. So we have a memory by default, by design. And to the class surprise that it was working quite nicely, I load tested a full ASP.NET Core application with a controller answering with JSON. The full application was able to run for minutes with quite nice throughput, and obviously with some memory leak, but still, because also ASP.NET Core team, every team in fact in Microsoft currently is trying to reduce allocations. We are able to sustain in such mode without GC for quite a long time. And this, as far as I remember, after 2 minutes, the process has a size of 300 megabytes. So it was really nice for the scenarios like serverless. Maybe it will be useful. But yeah, this is a Epsilon GC translated to .NET environment. And this is very interesting for development. I mean, writing something which you can plug into the whole runtime, and it is a starting point for writing your own GC is something which could be seen as a very boring exam or kind of thing that I could do at university, and I would probably then treat it as a very boring stuff. But then I'm doing it in my free time because I find it interesting. So, yeah, maybe sometimes things are quite surprisingly going. And yeah, this is the proof that memory was growing because I just plugged in my zero GC. Because the proof that it was working, and in fact I was using my own GC, not the default one. But maybe it's even another approach. Maybe we could get rid of the GC concept at all. And yes, the last part is about something that is not using GC, trying to not use GC completely. Very, very easy thing, yeah. This is a very academical stuff that is popping out in various scenarios. This is about just writing languages and type system that supports memory management. Not putting the effort of memory management on the runtime, but put it on the side of the language itself. Let the language support memory management, not the runtime. And there is a very, very nice popular language gaining more and more interest, which is called Rust. Have you seen Rust? So, a few hands raised. Rust is I believe Microsoft is also putting more and more interest in Rust. It was created by Mozilla for their browser, but it's open sourced. It is really, really popular language, which is low-level language. In fact, multi-level language, but it is like C++ version 2.0. New C++, unmanaged language without runtime and without manual memory management. It has kind of automatic memory management inside the language itself. And yeah, the whole concept in Rust is about ownership, because it is language that is tracking where we are using our objects and who owns them. And if we are doing something that would produce memory, we get a compilation errors. So, for example, we have code like here, which is could look as a very typical C# code. We are creating some string as a variable, putting it to variable, and then we have a second variable which is pointing to the same string. In case of .NET Runtime, this is a completely correct code. We have just two references to the same string. But in fact, in case of Rust, this is incorrect because we are moving the ownership between these two variables. And now we can't use S1 as a variable because it is just not, the value has been moved between those two variables. So I invite you to look at Rust because it is really, really nice language that manages memory on the compilation level, and you will get a lot of warnings like that. And those warnings also very, very nice, describing in fact what you are doing, what are the problems where you have create something that would provide memory leak, or maybe you were trying to access a pointer that is no longer valid. Everything here is maintained by the compiler. You get all those beautiful warnings that you translate in fact when you make a mistake. So Rust is a very nice, I will just skip some description of the Rust here. I really invite you to look at it because it is really, really a powerful type, has very powerful type system which manages memory for us without runtime. There is no managed runtime. It is just compiled to the native code, and it is working so fast as a C++ code. And all this comes to the mechanical sympathy, which is a term coined by originally it was term coined by a racing driver that was saying that, okay, as a racing driver, I don't need to be engineer, I don't need to design engines or design cars, but I need to have some mechanical sympathy how it is working, because from the perspective of the racing driver, obviously, car is something more complex. There are wells and driving pods. So racing driver should understand something how things are working. So as a summary, I invite you to look at the software, as a hardware, as a compilers, as everything that you are using, as something more complex than just a well. A racing driver are seeing a car and control car in much more complex way, because they need to understand how in fact it's working. And all this is things that I was learning in school and forgetting because it was boring by default, because it was I was forced to learn it, and now I'm rediscovering all this stuff as a very interesting, fascinating, and that's all. Thank you.
Thank you very much. Thank you for coming. Sorry for going over time because we started late and stuff. If you want to do any Q&A questions.